So today we're going to be going over 10F, which is factoring difference of two squares. In 10F, we're going to decide if a binomial can be written as a difference of two squares, and if possible, use the structure of a difference of two squares to rewrite a binomial. All right, so the difference of squares is a factoring pattern of the form a minus b squared, where whenever you have a minus b squared, so a squared minus b squared, so it would end up being factoring to a plus b and a minus b. So when can I use this pattern, the difference of two squares? The first word you see is difference. Is there a minus? The word difference means minus in math, right? Okay. And then the next thing you see the word two. Are there only two terms? And then the third part is squares. Are both terms a perfect square? And what we mean by perfect square is like 5 times 5 is 25, right? So 25 is a perfect square. 3 times 3 is 9. So 9 is a perfect square. It's a number where if you take the square root of it, you get, or it's a number where you can multiply the same number times itself and it'll give you that certain number. All right. So let's look at a couple examples down here. So first of all, difference of two squares down here. There's a minus sign. There's only two terms. And then you'll notice there's a perfect square right here. X squared and 49. So x times x will give me x squared, right? And 7 times 7 gives me 49. So the way we would write the difference of two squares would be x. I would have two factors. One of them's going to be x plus 7, and one of them's going to be x minus 7. And the reason you have the plus and the minus, they pretty much cancel each other out and make it to where you have that 0 as your b in the middle. All right, so look at the next one. Is this one a difference of two squares? 25x squared plus 16. Since there's no minus sign, this cannot be a difference of two squares. Okay, so it is not a difference of two squares. I'm using dots to abbreviate for difference of two squares.
So if it's not, are you subtracting?
So 7x times 7x gives me 49x squared. And then for 9, that would be 3 times 3. So then when I write out the difference of two squares at the bottom, when I write out my factors, so it would be 7x plus 3, and then what would the other one be? 7x minus 3. And that's my difference of two squares. So since we have right here, we have 4x times 4x gives me 16x squared. But the 10, there's not a number times itself that will give you 10. So this one is actually not dots. Not a difference of two squares. So on the last one here, 36x squared, 6x times 6x gives me 36x squared. But for the 9x, 3 times 3 is 9, and 3x times 3x will be 9x squared. So this is not a perfect square here. So it is not dots. So on this first one here, I have x squared minus 25. So first of all, it is a difference. There are only two terms, and then we have to need to check to see if they're perfect squares. X squared is x times x, and 25 is 5 times 5. So that would be, in both of them, it will be x plus 5 and x minus 5. So we need to check to see if this is a perfect square. Well, first of all, we need to see if it's a difference, which it is, as a minus sign. We have two terms here. Then we need to check to see if it is a perfect, or both of them are perfect squares. What can I multiply times itself to get 49x squared? 7x is 7x. So 7x times 7x gives me 49x squared. Then what about 36? 6 times 6. So both of them are perfect squares. So this would be 7x plus 6 and 7x minus 6. Of course, it doesn't matter which one goes first, plus or minus, as long as you have both of these together. It could be 7x minus 6 and 7x plus 6. So for the first one, this is a difference. Okay, we do have two terms. Now we need to check for perfect squares. 9n squared. What can I multiply times itself to get 9n squared? 3n. So 3n times 3n gives me 9n squared. Then what about 121? it'd be 11 times 11. Of course, you could take the square root of 121 and put it in Desmos, and it'll give you 11. That'll tell you that it is a perfect square. So it would be, your two factors would be 3n plus 11 and 3n minus 11. All right, so first of all, we need to see if this is a difference. And the first thing you'll notice, it is not a difference. So automatically you should know that it is not dots. So factoring completely. Now we will put together all the concepts from the last several class periods of completely factor expressions. Below are the steps you should think of. So the first thing you want to check, you want to see if there's a greatest common factor between all the terms. All right. Then, if there is a greatest common factor, you want to divide each term by the GCF. That's what we did the very first class period. Okay? If there's two terms, then you want to check to see if it's a difference of two squares. All right? If there's three terms, then you solve it with the exposal using swing and divide. So let's go through the first example, negative 28x squared plus 49x. Let's see if it's a greatest common factor. Let's see if there's a greatest common factor between 28 and 49. So remember, you can type in Desmos, you can type in GCF, put a parentheses, and then put in 28 and 49 and see if 28 comma 49. And it'll tell you if there's a greatest common factor. So if you do that, you will get 7. But remember when we went over this, I told you if there's a negative in the very front, we have to put a negative 7. Now, when you look at both of them, what else do they have in common? They also have an x, so I have to also put that x there. So 7x is my greatest common factor. Now, once we do this, we divide by 7. We divide each of them by 7x. So remember, we divide negative 28 divided by 7 ends up being. I'm sorry, it should be a negative 7. My bad. Negative 7. Negative 28 divided by negative 7 is a positive 4. And then remember, we have two x's up here. We take away 1. So how many do we have left over? We have 1 left over. So I'll put an x here. Then here, 49 divided by negative 7, x is a negative 7. And then you have an x up here. You take away an x. That means you don't have any x's left over. So it's just negative 7. That would be my final answer. We can't simplify it or break it down anymore. All right, so for the next one, we want to check to see if there's a greatest common factor between 9m squared and 64. Well, obviously, there's only an m in the first one, so it can't be an m involved. So look at 9 and 64 to see if there's a greatest common factor. So since 1 is the only greatest common factor, it's not a greatest common factor between 9 and 64 that's greater than 1. So next we need to check to see, since we checked that, there's two terms, right? So we need to check to see if it's a difference of two squares. See if it's dots. It is a difference. There's only two terms. Then we have to check to see if 9m squared and 64 are perfect squares. So go ahead and do that. So we want to check to see if it's dots. So looking at 9m squared, remember, you know that 3m times 3m is 9m squared. And then 64, you take the square root of 64, it'd be 8 times 8. So for this one is dots, so it'd be 3m plus 8, 3m minus 8. Those would be my two factors. Let's check for GCF here. 12x squared plus 1x minus 6. Obviously, since there's just a 1, there's not going to be a GCF. This time we have three terms. So if you look at the top, whenever we have three terms, we want to solve using the exposal. So let's go ahead and do that. So with our exposal, remember to get the top number is a times c. So 12 times, well, first of all, here's our a. Our b will be what number? 1. And our c will be negative 6. So to get our top number, the exposal is a times c. So 12 times negative 6 is a negative 72. And then the bottom number is just your b, which in this case will be 1. Now we're going to come up with our chart. Our factors are 72. 72 divided by 1 is 72. 72 divided by 2, 36. 72 divided by 3 is 23. No. 24? 20. No. Yeah, 24. 24. 4 gets into it 18 times.
18.
There you go. Thank you. 6 and 12. Yep. 6 and 12. 7, no, 8, and 9. There we go. Those are our factors of 72. So looking at the top number, am I going to add or subtract those two factors? I'm going to subtract those two factors because it's a negative number on top. So which one of these factors subtracts to give me 1? Negative 8 and 9. So I'm going to put negative 8 and positive 9, or 9 minus 8. So our next step, remember, we have to divide by our a, which in this case is 12. So we divide each number or factor by 12. So negative 8 over 12, if you were to type that in decimals and reduce it, negative 2 over 3. And 9 over 12 simplifies to 3 over 4. So now, remember, we bring this down here. So I put my x's. I bring down negative 2/3 right there. So x minus 2/3 on this side, and x plus 3/4 on this side. All right, our last step. You remember, anytime you get a fraction on this part right here, we have to swing the number in front of the x. So the 3, we swing in front of the x here, and that becomes 3x minus 2. The 4, we swing in front of the x here, and it becomes 4x plus 3. And those are our two factors. First, we want to check to see if there's a greatest common factor. So between 2 and 50, the greatest common factor between 2 and 50 will be 2. So 2 will be a greatest common factor. Do both of them have an x in common? No, they do not. So I can't put an x. All right, so 2 goes outside. So now I'm going to divide both of these by 2. So 2x squared divided by 2. 2 is 1x squared. And then negative 50 divided by 2 is negative 25. So now, taking off the 1 there, you should see that you have this x squared minus 25 in there. We can check to see if that is dots. All right, so on this part right here, we ended up with 2 times x squared minus 25. This is actually dots here. This is the difference of two squares, because x times x gives me x squared. 25, or 5 times 5 gives me 25. So it ends up being x plus 5 and x minus 5. But make sure you keep the 2 in front of the parentheses. Looking at the next one, we want to see if there's a greatest common factor between 2x squared, 12x, and 16. So looking at the numbers first, 2, 12, and 16. Is there a greatest common factor? So 2 is the greatest common factor. Can I include an x with it? Do all three of them have an x? No, the 16 doesn't have an x, so I can't include an x with it. All right, so now 2 is our greatest common factor. So now I'm going to divide each term by 2. So 2x squared divided by 2 is just x. 1x squared is just x squared, right? Negative 12x divided by 2, negative 6x. And positive 16 divided by 2 is a positive 8. So since we have 3 terms in here, we're going to use the x puzzle, and we're going to use swing and divide to factor this out. We're going to keep the 2 in front. But then when we come up with our 2 factors down here, we'll just have a 2 in the front. So let's go ahead and factor that out. So our A is what in this case? What number? 1. Our A is 1. Our B is negative 6. And our C is 8. So to find our top number, remember it's A times C. So 1 times 8 is 8. And then our bottom number is negative 6. That's our B. So now let's find our factors of 8. 8 divided by 1 is 8. 8 divided by 2 is 4. And 8 divided by 3 is a decimal. So there are our factors of 8. Are we going to add or subtract to get the, are we going to add or subtract to get the bottom number? Look at the top number. We're going to add because it's a positive number, right? So since that top number is a positive number, I'm going to add these 2 numbers. Which one of these 2 adds up to give me 6? 2 and 4. But notice we're trying to get a negative 6. So I can make both of them negative. So negative 2 plus negative 4 gives me a negative 6. Our next step is we divide by 1. Why do we divide by 1 again? Because it's your A. So now let's simplify it. Negative 2 over 1 reduces to just negative 2. Negative 4 over 1 reduces to just negative 4. Then we come up with our factors down here. I bring that minus 2 down, so x minus 2. I bring the negative 4 down, so x minus 4. Do I need to swing anything to the front? No. I do. Is there a denominator? A fraction? No. So I don't need to swing anything to the front. We do have something in front. My bad. 2, parentheses, x minus 2, x minus 4. There you go. That's our final answer. First thing we're going to check is the greatest common factor. All right. So what's the greatest common factor between 15, 20, and 20? 5. Can I include an x with that? No, because all three terms don't have an x, correct? So I cannot include an x with it. So it's just 5 that goes in front. All right, so now we're going to divide each term by 5. So 15x squared divided by 5 is 3x squared. Negative 20x divided by 5 is negative 4x. And negative 20 divided by 5 is negative 4. Go ahead and make our x puzzle. So my I make my A, B, and C. So on top is A times C, which is 3 times negative 4. And that's negative 12. That's how we get our top number. Our bottom number ends up being negative 4. Now let's come up with our factors of 12. Factors of 12 are 12 divided by 1, which would be 12. 12 divided by 2, which would be 6. 12 divided by 3, which will be 4. All right? So now, first of all, are we going to add these two factors together or subtract the two factors? We're going to subtract. Since the top number is negative, that tells me to subtract these two. So which one of these subtracts to give me 4? 2 and 6, right? But I'm trying to get a negative 4. So it'd be 2 minus 6 will give me negative 4. Max, what would be my next step? I'm going to divide by my A, which in this case is 3. So 2 over 3. If you reduce that in decimals, it doesn't reduce anymore, so it's already simplified. Negative 6 over 3. If I simplify that, it becomes negative 2. So now we're going to bring it down here. Hold on. Don't forget, like some of y'all did last time, we're going to still bring that 5 down. We're going to put x plus 2/3 and x minus 2. We still have to swing the denominator over in this part right here. We're going to swing that 3 in front. So it's going to be 3x plus 2 and x minus 2.